So for my topic, I'm going to be talking about the solubility of organic compounds in water. We'll first look at 5 basic solubility rules for organic compounds in water. The first, anything with a charged group is almost certainly water soluble. The second, any functional group that can donate a hydrogen bond to water will significantly contribute to the compound's water solubility. The third, any functional group that can only accept a hydrogen bond from water will have a smaller but still significant effect on the compound's water solubility. The fourth, other groups that would normally contribute to polarity, such as alkyl halides, will make a smaller contribution and pretty insignificant contribution to the compound's water solubility. And fifth, each polar group in a compound can handle up to and including 4 hydrophobic carbons from that compound. So we'll look at 2 examples here. We have a ketone and an alkyl halide. We can see clearly that the oxygen on the ketone would be able to form a hydrogen bond with water. However, nothing in our alkyl halide is there that would contribute significantly to the alkyl halide's water solubility. So our ketone, not our alkyl halide, would be water soluble. We have 4 other examples here. We have methanol, ethanol, butanol, and pentanol. Of these compounds, we can see that methanol has 1 carbon, ethanol has 2 carbons, butanol has 4 carbons, and pentanol has 5. Because we know that each polar group can handle up to and including 4 hydrophobic carbons, we know that methanol, ethanol, and butanol would be water soluble. However, pentanol, because it has 5 pent, would not be water soluble. One application of this that we've seen this semester in lab is through our determination of the partition coefficient, where we mixed 2 immiscible solvents and then dissolved a compound in those immiscible solvents. In our lab, we used a system of benzoic acid, methylene chloride, and water. So we mixed the methylene chloride in water and then dissolved benzoic acid in it. Initially, we might look at our benzoic acid and think, oh, it has this nice little polar group here that should be able to bond with the H bonds in water. It'll be water soluble. But as we found in our lab, this bulky ring here overwhelms the polar bond capability that the compound has, making it not water soluble and more soluble in the nonpolar methylene chloride. One of the things we might think about as we examine it in the lab and then also just in our classes, why does this matter? Understanding the solubility of compounds, organic compounds in water, why does it matter to us? However, it does matter a lot in a pharmaceutical setting when scientists are trying to understand the distribution of drugs in the body. Often scientists will take 1 octanol, which you can see here. It's very hydrophobic because it has 8 carbons that overwhelm the polar group, and water, those are the 2 immiscible solvents, and they'll mix a compound together in those to determine what the partition coefficient is. We know that our partition coefficient would be the concentration of our compound found in 1 octanol versus or over the concentration of our compound in water. If the partition coefficient was larger, the numerator was larger, then the majority would be distributed in hydrophobic areas of the body. If the partition coefficient was smaller, the denominator was larger, more was found in the water, then the majority would be distributed in the hydrophilic areas of the body. The reason that this matters to scientists and to pharmacists as they're building and creating drugs is they can then target a drug to a specific part of the body. So example, if they had something with a large partition coefficient, more likely to be found in hydrophobic areas of the body, they could target a drug to address any kind of issue or disease in a hydrophobic area of the body, like the phospholipid bilayer in cells, where the hydrophobic fatty acid tails are found. If they had something with a small partition coefficient, so it would be more hydrophilic, they could target that drug to be found in hydrophilic areas of the body, like the serum in blood. So that's just a little bit about the solubility of organic compounds in water and some of the applications in our world.